So I guess you have heard the joke about fish walking into a bar. But what I'm here to talk about is how fishes survive 800 bars of pressure, which is 700 times the pressure that we are experiencing right now. To give it a more realistic context, most of our watches would break down at 0.02 miles of pressure. However, sperm whales regularly dive to a depth of 2 miles. The pressure difference that they experience during this dive is about 300 times the surface pressure. Beyond this, a lot of fishes and organisms have been found even at a depth of 4 miles. So that's right, guys. Life happens in extreme environments. Organisms have been found in extreme cold, extreme heat, extreme stall conditions, and extreme pressure. And one of the most important ways to survive these conditions is to understand how these organisms keep their protein stable. So why is it important to keep their protein stable? That's because proteins have important jobs to do in the body. And the only way that they can do these important jobs is if they remain folded in a compact shape. The interesting thing is proteins are never ever entirely stable. They can lose their structure very easily and consequently their function. What I'm trying to do is trying to use high pressure experiments and computer models to figure out how fishes keep their proteins stable at such high pressures. So suppose you are a fish and you wanted to keep an important fragile cargo protected. What will you do with it? So firstly, you can bubble wrap it, right? Secondly, you can pack a lot of the things together so that they don't rattle around. So what we have found is this is similar to what a fish does. Firstly, it manufactures a lot of small molecules that surround the protein, kind of like a bubble wrap, so that the shock is absorbed. Secondly, it packs a lot of the proteins together so that the pressure experienced by each of the proteins is reduced. Now you'll be asking, why does this matter? So currently, Earth is the only place that we know where life happens. And life at such depth matters because that is where life is supposed to have originated in the first place. Currently, we have only explored 5% of the oceans. Understanding how these small things can help fishes survive at extreme pressures is critical for us to understand how life originated in the first place. And it is also important for us to figure out whether life can exist at other planets like Mars. So as we go forward, figuring out how these things matter can help us understand the next frontier space. Thank you.